Hello everybody. Today I'm going to start on a new set of problems. I got these problems from JEE Advanced Physics test of 2023, and we're going to start today with section 1. So here is the test, section 1. You can see the problem in section 1 have 4 answers, and any one of them could be wrong or could be right. And if you mark any of the wrong answer as right, then you get a negative mark. So you have to be very careful. It's a test of this section tests all or none kind of thing, like if you only know the right answer. So you have to be very careful. Usually their parts are interconnected, so sometimes you get one part wrong and you have to use the answer from one part to the next part. You probably gonna get a negative mark for this, so you have to be extremely careful for this section. Okay, so let's look at the first question here. So here is the first question. So first question is kind of like it is a mechanics problem, and actually a relatively simple problem, because if this is you're taking the advanced test, that means this question is probably you practice like this quite a bit. So we have a ball. All this question is simple, but it's actually ambiguous in some ways, because these answers you will see that the very first answer here is you have to test it, and it only this answer assumes something which is not part of the description. And if you don't assume the correct, you'll be wrong. For instance, if you assume that over here when the ball is moving, you assume that the ball is also rotating and translating, like as if it was not sliding down this, but actually was picking up rotational speed, maybe rolling down it. Then you will have a kinetic energy from rotation and translation of the center of mass, right? So you're supposed to if you assume that, then you don't get A is a correct answer in there, by the way. We'll see, but you don't get that. So you have to kind of sometimes get a right assumption when you're reading the problem. So we'll just assume that kinetic energy here will be just half mv square. Okay, and that will set us on the right course. So the ball, let's read through the problem. You can pause the video and read this problem out for yourself, and maybe here is the whole picture, and you can try to address this problem, solve all the parts. I will just display to you. And here is a coordinate that you must use. Usually use x and y, but they're using x and z, and the answers actually use the unit vectors along the x direction, and it will be a vector along the z direction also. So in order for you to use, make sure you kind of follow this coordinate system. Okay, so suppose you have read this problem. I'll just quickly go through it. So this ball slides down and ejects horizontally here, comes out of this ramp. You don't need the curve of the ramp, it's just curved, we don't know, so we just use a energy balance between here and here. We're supposed to ignore air resistance, all the frictions you have to ignore. So the energy is conserved between here and here, and then this will do a projectile motion from here to here and fall a distance, horizontal distance d, horizontal distance d from here to there, and it's going to come at some velocity, say this is u, let's call it w, it comes to velocity w here, but then it goes to when bounces back, its velocity is v, and then this is another projectile motion, and comes up to height h1. So you'll have to figure out what this h1 is in terms of all the other things. You'll find that this h1 will actually is h when we work it out. Okay, so let's do it. Okay, so I am going to kind of do in a separate piece of paper, and I'm going to just redraw this picture, and I will pause this video. Okay, so I redraw the picture, and so there are actually point A, point B, so the A to B motion. So you have a A to B motion, and then you have a B to, let's call this point C, B to C motion, and then we have a, at C you have a bounce, a C, which is elastic. So this is inelastic collision. With the floor, that's the floor, which is of infinite mass, so we'll say velocity doesn't change, two-body collision. And then you have a C to D, this point we just can call it D, C to D, and so this is so there are like four separate events or motions that you have to analyze. So there's A to B. A to B is if I look at A to B motion, A to B motion is going to be energy conservation. So this is energy conservation. B to C will be projectile motion, and C to D will be a projectile motion or free fall in 2 dimension, right? So you probably have to do this in like 2 to 3 minutes, or if it's relatively simple problem. So let's do the A to B motion, and that should let's put the answers out here that we are looking for. So into A to B motion, that this is all about A to B motions. I should be able to find out what U0 is, right? So the question is A correct or not. So A to B motion, clearly energy here equal to energy there. Here this is all kinetic energy, so we can say this is the potential energy 0. So potential energy equal to 0 reference. So this potential energy will be mgh, and velocity or speed is 0 there. So so energy at A equals energy at B. Energy at A just mgh 0, and then this is kinetic energy, and 0 plus half mu square, mu naught square. And clearly this you can solve for u naught. U naught will be positive because this is the x-axis and this is the z-axis. So this is pointed towards the positive x-axis. This will be positive. U naught is greater than 0. So u naught is going to be square root of 2gh. So u naught vector is square root of 2gh x hat. So the A is correct. Part A is correct. So we got the A correct. So A is correct. How about Now that we know u naught, we can try to address a to b motion, I mean b to c motion. Now so you can see the acceleration is only along the z-axis, so b to c. There are a lot of ways to save time here, because in the x direction you just have let's call this t, let's call t at b is 0 and t at c is denoted by t. Okay, although the t may not be necessary, but there's let me do it my way. Okay, so along the x direction I'm going to get two equations. u0 will be constant, so over here the w, it's x, w x component, this velocity at the final velocity at c is x component will be u0, same as the initial, and the distance will travel, d will be just wx is constant, is going to be u0 t. So you can say equation 1, equation 2. So two equations along the x-axis. Along the z-axis, recall this is a sub x is 0, so no acceleration along the a sub z is going to be minus g, because z pointed up and the axis pointed up and the gravity direction is pointed down, and z stands for 9.8 meter per second square. So this is positive number. Symbol itself is just a positive number, so you have to minus sign. You have to put a minus sign there. So using that, and you can see the wz square will be 0 square plus 2g, and the amount of distances traveled is 3h. So this positive, this was negative, and this negative became positive, and so this comes from a formula along wz square equal to wz 0 square plus 2az z final minus z initial. So z final, if you put a coordinate system here, z initial is 0, z final equals to minus 3h. So that's why minus 3h, 0, and minus z makes it a positive here. Okay, so you can see the wz, that's one equation, so this is 3, and we can use the time component to actually get one more equation, right? But we may or may not need it. All right, so let me look at, if you over here you can get the t is d over u0 and wx u0, so we might not need it. So let me carry on. I'm not going to write this in the equation, see if I can get away with it. So here is a wz is going to be two values. Wz will be plus or minus square root of 6gh, right? Okay, so we've decided between plus and minus, and if you look at this w, if you put the axis, x-axis here and z-axis here, and this vector is pointed this way, then this w vector will have a negative z component. So this out of the two, you'll have to do z equals to minus square root of 6gh. Okay, so now I have a wx, which is u0 is already known, and wz is already known. So one of the question is this 60 degrees, and that angle is the same as this angle. So this side is wz, and this projection over here is wx. So you can see that this theta is same as that theta. So we have wz, wx, and this is theta. So if I just take positive things, so tangent theta is wz over wx, and that should give us square root of 6gh over square root 2gh, which is clearly square root of 3. That just tells you theta equals to 60 degrees, and that kind of the C is correct. That just makes C is correct. This means C is correct. So we decided about A and divided by C. We haven't decided about B yet. So what is well, V is after the bounds, right? That V is after the bounds, the direct the magnitude and after the bounds. Actually, we don't really need to find that to answer this question about this. It is just the direction is wrong. You can see that after the bounds it came in like this and went like this. This is the V direction. So if you look at the axis pointed, so this is positive x direction, this positive z direction. So each projection is v sub z. V sub z, I expect it to be greater than 0, but over here it says so, but B says v sub z is minus square root of 2gh, so which has to be wrong, because so that I really don't have to solve to get B to be wrong. So my answer will be B is not correct. So we got so far we got A correct, B not correct, and C correct. Now we have to do D. So for D we really must solve this part, right? Must solve this part, this bounds. Now if you didn't have time and you're running out of time and you don't know D, then don't mark D right or wrong. So it's better to leave it alone and you get a partial credit, very fair amount of partial credit. So to D is so to get D, we came in at a W vector and we bounce back at C in the V direction, and over here is the top of the trajectory. So this is D. So we have to do two analysis of what happened at C. At C is an inelastic collision. So inelastic collision, they tell us in the problem statement, if you go back, it says coefficient of restitution of the ground is 1 over square root of 3. So you have to know what the coefficient of restitution actually is in giving you, the information it's giving you. And if one way to tell coefficient restitution against this ground, against the ground will be very simple. Against any two colliding bodies, it's very simple. So coefficient of restitution coefficient of restitution is basically what is the final ratio of the final. Of course they're going to be in the opposite direction, so you got to put a negative sign. So this is, let's call this VI, and this call this V final, and this is the ground. Okay, so but it was not ground, it was say part object 1 and my ball was object 2. So I could do V2 perpendicular final minus V1 perpendicular final over V2 perpendicular initial minus V2 perpendicular initial and V1 perpendicular. So we can, over here it will be zeros, so just the ratio of over here it will be just the ratio. So this is 1 over square root of 3 is given, and what's given is minus V, this is the final thing, is Z component, and the Z component is the initial thing, WZ. So this from, because we know what WZ is, worked out earlier, WZ was minus WZ was minus square root of 6ZH. Then this minus cancels, that's minus, so the VZ will be rightfully plus 1 over square root 3 square root of 6GH, right? So this square root of 3 goes inside square root, this becomes a 3 and this becomes 2, and that's equals square root of 2GH. Well, so if I look at the y motion, so we were looking at the y motion, and this is height h1. So clearly, if it's just y motion is the one dimension, right? Just the z motion, I mean z motion. So this this going with a square root of 2gh, it goes to 0 velocity. Vz is equal to 0, and it goes a height h1. Well, clearly this can happen, or you can just apply one-dimensional motion along this axis, and az equals to minus z because it's pointed down. So using this, you should be able to immediately see that square of this minus square of this, right? A final square, 0 square minus square 2gh square equals to minus 2g times h1. And so this just tells me h1 is just h. All right. And over there, earlier we worked out, we had d equals to this stuff, right? So if we knew t here, we already know what u0 is, then we would have actually used that d over here, d over h1, and we would have checked whether this is correct. All right, so it turns out we should be able to get the t from the equation we didn't want to write down. I just delayed it because I want to make sure that you know that sometimes in the test you don't want to do things which you don't need to do. Okay, so how about we going back to the this B to C motion, and we need the time parts. So time part, you can do WZ equal to start with 0 minus 2GT. So that equation, if we use that equation, we should be, because we already know what WZ is. So now I'm going to use a clean place here in the same. So WZ equals minus square root of 6GH, okay, and so WZ equals to minus 2GT, and D equals to square root of 2GH. We have these equations. So definitely you can get T and plug in here. D equals square root 2GH square root of 6GH over 2G, and so H equals to H1. So let me do it out. So square root of 12 G square H square of, let me see, is equal to 3 times 2GH numerator over 2G. 2G cancels out, and H is same as H1, so D over H1 is square root of 3. Let me check. I think while I was doing this calculation, I kind of made a mistake here because I read 2 here. That's incorrect, right? You have a V final equals V initial plus AT. So you want AT, A is minus G. So I can, the factor of 2 is coming from there. That was a mistake I made. And so this 2 is not there. This 2 is not there. This 2 is not there. So this 2 doesn't cancel. So this becomes 2 here. So sometimes you can actually catch your mistake, because if it's so close to the answer that's given, and so you have to wonder where there's a factor of 2. So you should, if you have problems like this show up in the exam, then you should trace it. It's very easy, there's a few steps, just trace it backward, and that should help you find the stuff. Okay, so it looks like D is correct. So what I got is A is correct, B is not correct, C is correct, and D is correct. Okay, so that's the problem number 1.